Hello, my name is Mike Duffy, and in today's food science video, we will be discussing the process of starch retrogradation. First, let's break this term down. Starch is a polysaccharide made up of several monosaccharides of glucose that functions as a carbohydrate. It is found in animals in the form of glycogen, and is also common in plants such as corn and potatoes. Starch comes in two forms in plants, amylose and amylopectin. As seen in this image, the main difference between amylose and amylopectin is the branching. Amylopectin has much more branching in its structure compared to amylose. Amylopectin is also more commonly found in nature compared to amylose. Starches that contain only amylopectin are considered starchy and will be discussed later in this video. The next part is retrogradation, which is a phenomenon that occurs during the cooling of gelled starch. When the amylose and amylopectin molecules retrograde or realign themselves. This process can cause reassociation or recrystallization of the starch and stall the baking process. Starch retrogradation occurs when starch-based foods, such as pie, for example, are exposed to the freeze-thaw cycles or moisture migrations in food. This process usually occurs when a food is being stored in a place such as the refrigerator. There are four main effects of starch retrogradation. Number one is increased firmness of the crumb. Number two, it can change the flavor and aroma. This can be for better or for worse. Number three, it can cause a loss of crispiness. And number four, it can increase the texture and nutritional abilities of food. So sometimes starch retrogradation will be done on purpose to improve the food, but sometimes you want to avoid that. There are some other important facts to know about this process. Starch retrogradation will decrease starch digestibility, and also it is affected by storage temperature, as seen with the freeze-thaw cycles affecting how it goes. Also, the composition of salt or sugar, the water content, and anti-stalling enzymes in the food will also have a great effect on how quickly or slowly starch retrogradation will occur. Another important fact is that starch retrogradation occurs more readily with amylose than amylopectin because amylose is a smaller unbranched molecule, as will be seen in the next image. In this picture, the top pie was made with an unmodified cornstarch containing both amylose and amylopectin, and it is exhibiting a process called syneresis, which is the seepage of water out of an aging gel because of the concentration of the gel. Now, the bottom pie was made with a waxy cornstarch, which contains 100% amylopectin and is not exhibiting syneresis because the bonds between amylopectin do not tighten as much because of its branch structure, allowing it to last longer. Thank you for watching this video, and I hope you enjoyed this information on starch retrogradation.